colourless liquid at room temperature. Its boiling point is 80 degrees Celsius. It's found naturally in crude oil and in fact smells a little like petrol. On an atomic level, benzene is made up of 6 carbon atoms covalently bonded in a ring. Each carbon is also covalently bonded to one hydrogen. This makes it a hydrocarbon. Carbon usually forms 4 single covalent bonds, and these carbons at the moment only have 3. The molecule now does something very special. The one unpaired electron from each carbon becomes conjugated into the ring. This means they have free movement around all 6 carbons, and this gives benzene the property of aromaticity. You might have thought aromaticity simply meant nice smelling, and while that's often true, scientifically the term refers to conjugation in ring-shaped molecules. There are various ways of showing benzene's aromaticity, like these for example. The most common way you'll see benzene drawn in a textbook is like this. But be aware, this is done only for convenience. Benzene can be dangerous as it's carcinogenic, that is, known to cause cancer in sufficient doses. The magic happens when we're able to join benzene rings to other organic molecules. Some of the most important and useful drugs are made this way. For example, here's aspirin, one of the most famous painkillers in the world. The important thing to remember here is that it's almost impossible to do an addition reaction on benzene. Addition destroys the aromaticity of the ring, a process which needs a lot of energy. What does often happen is substitution reactions, where one of the protons is kicked out of the compound by another species, which takes its place, and the molecule keeps its aromaticity. This can happen more than once, and the benzene is said to be mono, di, or tri-substituted. What sort of chemical species will we need to cause a substitution reaction to happen? Remember, the atom in the benzene being attacked is one of the carbons, and these carbons have lots of electrons moving around them. Pause the video and have a think, then resume. The answer is we will need an electrophile, something that will be attracted to all those electrons. Benzene is quite a stable molecule as it is, so we need a strong electrophile. So a species with a positive charge is often necessary. For example, have you ever heard of Cl+, a cation made from a chlorine atom? Or this nitronium ion, NO2+? Well, they exist and are widely used in benzene chemistry. In fact, NO2+ is reacted with benzene to form trinitrotoluene, also called dynamite.